Hello everyone, welcome to this session of class 9 mathematics, and I am your Anu for mathschool.1. Yesterday we have been seeing, that is last class we have been seeing polynomials and important problems in polynomials. We have started with important problems, isn't it? So today we will continue with the same chapter, polynomials and the problems in it. Okay, so yesterday I stopped with finding integral roots and rational roots of a polynomial, isn't it? So when we find rational roots, you should keep in mind that there will be the factors, that is, for rational roots, as I said yesterday, see ax cube plus bx squared plus cx plus d. If it is like this, okay, see, the leading coefficient will not be equal to 1, there will be a leading coefficient and the constant term is there. Unlike integral roots, in integral roots you have the leading coefficient to be 1 and the roots of the polynomial will be the factors of the constant term, isn't it? Now for rational roots it is not like that. You have a leading coefficient and you have a constant term, and the rational root will be in the form of d by c, so that d will be, it can be generally written as b by c. Let us don't get confused with d and c. So this is in the form of b by c, the actual form of rational root in the form of b by c, and this b will have the same factors of the constant term and c will have the factors of the leading coefficient. Okay, so if I list out all the factors of a and d, that is the leading coefficient and the constant term, and I find out the rational roots, I may get some 5 to 6 or even 10 roots. So 10 factors or 10 roots I may get, but substituting all the roots and all the roots in the polynomial and seeing whether it tends to 0, the value becomes 0, is a tedious process, isn't it? That is why in the last class I showed you, by when you get one root, okay, the root, that is another thing to be noted, is the number of roots is determined by the degree of the polynomial. If the degree of the polynomial is 3, you just have 3 roots. So by finding one root, if you get just one root, by substituting each and every factor, just first if you get for one of the roots, if you get 0, you just stop with that and take that root. Suppose if you are getting x is equal to 2, when you substitute 2, the polynomial becomes 0. Bring this 2 to the side, x minus 2 is equal to 0. So this is a linear polynomial. X minus 2 is a linear polynomial, and you have to divide the whole polynomial by this linear polynomial x minus 2, because since 2 is a root, x minus 2 will be a factor of the polynomial. It will divide the polynomial exactly. So you need to divide the cubic polynomial by, suppose if it is a cubic polynomial, you can divide it by a linear polynomial and you will get a quadratic polynomial as a quotient. So now this quadratic polynomial can be factorized, that is, it can be made into its factors by splitting the middle terms, isn't it? So that is what I have done in the last class, and you have seen how we obtained factors, the next two factors, by factorizing the quadratic polynomial, because quadratic polynomial's degree is 2, so you have just 2 roots for it. So already one root is found out, so you get the other 2 roots by that way. So that will be easier for you instead of that lengthy process of substituting each and every factor into the polynomial and finding whether you get 0 or not. Okay, do you understand? So you can follow that method too. Now after finding the integral roots and rational roots, now we'll move on to the next sum, that is finding 0 of the polynomial f of x is equal to 2x plus 5 and g of x is equal to cx plus d. So there are two polynomials given in the sum. So this is f of x is equal to x plus 5. Now how do we find the root of the polynomial? So the root of the polynomial can be found out in case of any polynomial. If it is given, if any polynomial is given, the way you need to find the 0 of the polynomial is just substitute f of x is equal to 0. put f of x is equal to 0 and find the value of x. So whenever you are asked for the root of the polynomial, you should equate the polynomial to 0 and find the value of x. So that value of x will be the root of the polynomial. Okay. So now 2x plus 5 is equal to 0, or 2x is equal to minus 5, or x is equal to minus 5 by 2. So this is your root of the polynomial. What does this root of the polynomial mean? What is its significance? You just substitute this in the to check whether this is the real root of the polynomial, whether we have found the answer right or not. You just substitute the x in the given linear polynomial. 2 into minus 5 by 2 plus 5. So what will be your answer? 2 gets cancelled, so minus 5 plus 5 will become 0. So since you get 0, the value is right. So the x is equal to minus 5 by 2 is the root of the polynomial. Do you understand it? Okay. Now for this again you need to substitute cx plus d is equal to 0, or cx is equal to minus d, or x is equal to minus d by c is the root of the given linear polynomial. Now do you understand how do we find the root of the polynomial or 0 of the polynomial? Yes, right. Now we'll move on to the next sum. Actually, we can, I'll be able to show you the finding out roots for quadratic polynomial and a cubic polynomial. That will move on to the next part, that is where we will try to factorize the quadratic polynomial. I will say you the methods to factorize the polynomial, and then we'll be able to find out the factors very easily. Okay, so just for up to this, for linear polynomial, this class we'll stop with the linear polynomial and we'll move on to the next sum. The next sum is using remainder theorem, find the remainder when f of x is divided by g of x and verify the result by actual division. So what they have asked you is you should use remainder. You should use remainder theorem. So what does the remainder theorem says? See, when f of x is divided by g of x, when f of x is divided by g of x, you will have a quotient q of x plus some remainder r of x. Okay, so this is your, we know when this is divided, when f of x when divided by g of x, no, we don't get, we shouldn't add this plus, you get some remainder r of x. Okay, so that is what I have given you in the division algorithm, that f of x is equal to g of x is the divisor, into q of x plus r of x. That is, you have a remainder here, you have a quotient here, and f of x is divided by g of x. So g of x is the divisor. Okay, so now this r of x, how do you get this r of x is, if they have given you a root, okay, if they have specified x is equal to some number as root of the equation, root of the polynomial, then you substitute that root in f of x. Okay, in f of x, in the place of x you substitute the root. Whatever value you get, that will be your remainder. We know that f of a. See, if x minus a is a factor of f of x, then put x minus a is equal to 0, then x is equal to a, then substitute that a in f of x. This f of a is nothing but the remainder. So that is what remainder theorem says. Okay, if there is no remainder, actually if f of a, we don't get f of a, that is we don't get means if you get 0 as a remainder, then this x minus a is a exact factor of the polynomial. It divides exactly without any remainder. Okay, that is factor theorem. Now we will move on to the sum. F of x divides g of x. Now what is f of x? F of x is equal to x power 4 minus 3x squared plus 4, and what is g of x? G of x is equal to x minus 2. So as we have seen already, isn't it? So g of x divides this polynomial, and we need to find the remainder first by remainder theorem. So first put x minus 2 is equal to 0, we get x is equal to 2, isn't it? Now substitute 2 in x, that is 2 power 4 minus 3 into 2 squared plus 4 will give you 16 minus 3 into 4 plus 4, that is 16 minus 12 plus 4, that is 20 minus 12, which is equal to 8. Now you get 8. So you have some value for f of 2. So what is that value? This is your remainder. When the given polynomial f of x is divided by x minus 2, you have the remainder 8. Now this is according to the remainder theorem, isn't it? We have found f of a and this is according to the remainder theorem. Now we have to check this whether 8 is a remainder or not by actual division. Now I will tell you how to divide it actually. So we are learning about two methods to find the remainder. Now x minus 2 divided by x power 4 minus 3x squared plus 4. The division we actually did yesterday too. But let us understand it more clearly today by having an example. 3x squared plus 4. See, I don't have the cubic term and I also don't have the linear term, that is x term here. So I put 0 for my convenience. Now I start dividing. How do I divide? Now see the first term in the polynomial, that is x power 4. X power 4 need to be added with the divisor, the largest term, the largest power holding variable, that is x power 4 here, just x. So it gives you x cube, isn't it? So that x cube has to be written here. Okay, this is the procedure for dividing. So x cube power x cube into x will give you x power 4. X cube into minus 2x cube is minus 2x cube. Now subtract, change the signs. So you have 0x cube plus 2x cube, this will give you plus 2x cube, this gets cancelled. Now bring this minus 3x squared down. Now what I need to do is, you take 2x cube. Every time when you find the quotient, you just see the first term, 2x cube, it has to be divided with this x, the divisor. So what you get? 2x squared. So put that plus 2x squared because the sign is plus here. So plus 2x squared into x will give you 2x cube and this is minus 4x squared. Do you understand? So now change the sign by subtracting. Now plus 4 and minus 3, so that is plus 1, and now bring this 0x here. Now divide x squared by x, you will get x here. So put x to the quotient, you get x squared minus 2x. Now subtract, change the sign, you get 2x, bring this 4 here. Okay, now what you need to do is, see, divide this 2x by x, you get 2 here. So put plus 2 here. So what do you get? X 2x and this is minus 4. Now change the sign, minus, this becomes plus. Now 4 plus 4 is 8 for me. So see, I've got the same remainder. That is, by remainder theorem, I've got the remainder 8, and by actual division too, I've got the remainder 8. Now, do you understand the actual division of polynomial by a linear polynomial? Yes. What you need to do is, you just have to see the first term divided by this x. So whatever you get the answer, you put it here and multiply. Next, when you subtract and get the answer, you just divide this number by x again. Whatever you get the answer, you put it in the quotient, okay, with the sign. Remember the sign. Signs should be same. So this is how we do actual division, a polynomial, given polynomial by a linear polynomial. Do you understand? So the theorem, by theorem we get a remainder and that equals the remainder which we get by actual division. Okay, so we'll move on to the next problem. What is the next problem is, the polynomials, there are two polynomials, leave the same remainder when divided by x minus 2. You have two polynomials and an unknown in it. Okay, so let me write. The two polynomials are 2x cube plus ax squared plus 3x minus 5. So this is one polynomial. The other polynomial is x cube plus x squared minus 4x plus a. So what they have told us, they leave the same remainder when it is divided by, when the both are divided by x minus 2. So x minus 2 is the divisor for both the polynomials and it leaves the same remainder. If it leaves the same remainder, you need to find the value of a. So here it is, there is one a and here one a. So you need to find a. So what actually, you leave the part of finding a. First we'll do the first part. So it leaves the same remainder. So how do we find the remainder? Like the previous problem, you just substitute the value of x in the polynomial. So x minus 2 is equal to 0, that is x is equal to 2 we have. Now substituting the value of x in the polynomial, we get 2 into 2 cube is 8 plus a into 2 squared is 4 plus 3 into 2 minus 5. We get 16 plus 4a plus 6 minus 5. Now 4a, here 6 minus 5 is 1, 1 plus 16 is 17. Okay, so now this is 4a plus 17 is the remainder for the first polynomial when divided by x minus 2. Okay, so this is your remainder. We don't know the value of a, so we have left it as it is. Now for the second polynomial, I substitute x is equal to 2. So 2 cube is 8, 2 squared is 4, minus 4 into 2 is 8 plus a. Now 8 and 8 gets cancelled, you get 4 plus a. So this is your remainder for the second polynomial when divided by x minus 2 according to remainder theorem. Now we'll move on. Now we'll come to the problem. What does the problem say? It leaves the same remainder when divided by x minus 2. So it leaves the same remainder means 4 plus a should be equal to 4a plus 17, isn't it? That is the meaning for having the same remainder. So these two reminders are same. Now we are equating. So bring this 4a minus a and 4 minus 17. So what is this? Is 3a and this is minus 4a minus 17 and this is 30 for us, isn't it? So 4a minus a is 3a and 4 minus 17, 16 plus 1 is 17. Okay, 4 minus 17 is minus 13. Therefore, what is a? A is equal to 13 divided by 3. So the value of a is minus 13 divided by 3. So do you understand? So let us check. 2 8s are 16. A into 4, 3 into 2 6 minus 5, that is 16 plus 6 22 minus 5 17. Okay, there 8 plus 4 minus 8 plus 8, 8 gets cancelled, 4 plus 8. So this is your answer for A. So that is how we find out A when divisor is given and there are two polynomials. When the linear polynomial divides the polynomials, they leave the same remainder, and by equating both the remainders we get the value of unknown. Okay. Now the next sum is, without actual division, prove that the given polynomial is exactly divisible by another polynomial. Okay, without actual, we should not do actual division, but we should prove that this polynomial, one polynomial divides another. It divides another. So how do we do? What does, according to the remainder theorem, we'll take remainder theorem. According to the remainder theorem, when do we say a polynomial divides another polynomial exactly? When do we say? When the remainder is 0, isn't it? Any number divided by another number, if you get a remainder 0, you say the divisor divides exactly the dividend, isn't it? So that is what we need to follow. We need to find the remainder to be 0. We need to prove the remainder is 0 when we divide the polynomial with another. Okay, so let us start the problem. So the given polynomial is 2x power 4 minus 6x cube plus 3x squared plus 3x minus 2. So now this polynomial is divided by x squared minus 3x plus 2. Okay, so this is your given polynomial. Now this is quadratic and this is biquadratic polynomial. Now without actual division, we should not divide it as we did before. Actual division, we should not do that. So first, for that, for applying remainder theorem, we need the value for x, isn't it? We need the roots actually. So how do we find it? So this x squared minus 3x plus 2 has to be factorized, so such that we'll be able to find the values of x from it. We need to extract the values from it, isn't it? So x squared plus minus 3x plus 2. So as I said before, this can be factorized by a method called splitting the middle terms. What does that mean? You split the middle terms such that we take two numbers. There are two numbers. See, so two numbers here. You take 1 and 2. So 1 is equal 1 into 2. You need to multiply both the terms. Coefficient of this and constant term 1 into 2 will give you 2. So you need to find two numbers such that their product is 2 and their sum is minus 3. Always looking for the middle term, you need to split the middle term, so that when you split the middle term to two terms, that two terms product should be this 2 and the sum should be the middle term. Do you understand? So sum two numbers when multiplied should give you 2. The same numbers when added should give you minus 3. So that is what this is called the splitting the middle terms method. So which will give you minus 3 and it should give you minus 2 also. So let me try minus 1 and minus 2. Yes, minus 1 into minus 2 is 2. Minus 1 plus minus 2 is minus 3 here. So we are getting it exactly. So I split it like this: x squared minus 1x minus 2x plus 2. So that is x into x minus 1. Put this x minus 1 as it is here. You carry this x minus 1 here. Now what is the term left? Minus 2. So x minus 1 is common into x minus 2. So I have factorized x squared minus 3x plus 2 into x minus 1 into x minus 2, isn't it? Now it is very simple. You just equate it to 0 to find the value of x. X minus 1 is equal to 0 or x minus 2 is equal to 0. So x is equal to 1 and x is equal to 2. So see, you have got two values for x. Now after finding the two values for x, you just substitute the two values in the above polynomial. So let us substitute 1. For x is equal to 1, we have 2 minus 6. I am substituting it directly. So 3 plus 3 minus 2. So what do I get? See, 3 plus 3 is 6. 6 minus 6 and plus 6 get cancelled. Minus 2 plus 2 get cancelled. You get 0. So x is 1 is a factor. Now we need to prove for x is equal to 2 also. So only when two values satisfy, you say that the quadratic polynomial divides this exactly. Now 2 in 2 power 4 is 16. 6 into 8 plus 3 into 4 plus 3 into 2 minus 2. Let us solve. 32 minus 48 plus 12 plus 6 minus 2. Now 32 plus 12 is 44. 44 plus 6 is 50 minus 50. So this is also 0. So x minus 2, x minus 1 both satisfies the equation. So both are factors of the given polynomial, and we have factorized this x minus 1, x minus 2 from this quadratic polynomial. Hence, without the actual division, we have proved this x squared minus 3x plus 2 divides the above biquadratic polynomial, because we have got the remainder 0. See, remainder 0 means we have substituted f of 1 and f of 2, 1 and 2 in the polynomial, and we have got 0. So that is according to the remainder theorem, isn't it? So when you get a remainder 0, then the factor, then the divisor is an exact factor of the polynomial. Do you understand? So up to this, we have learned to apply remainder theorem, and we have also learned how to actually divide one polynomial by another, and we have also learned factorization by splitting the middle terms and finding the roots from it, isn't it? So up to this, we'll stop with this in this class, and in the next class I'll continue still some more problems in this chapter. So until then, it's bye from Anu from mathschool.1. Thank you.